Okay, so now the question becomes, how are we going to take one of these systems of equations and get it into one of these workable forms that we were talking about? Well, to do so, we're going to use what is called elementary row operations. So we're going to, like I said, use the augmented matrix to essentially solve a system of equations by the addition/elimination method. So what we could do back when we were, before we had matrices, these were some legal things you could totally do, okay? Number one, you could interchange two equations. Hey, if you wanted to, you could write the bottom equation on the top and the top equation on the bottom. No biggie, right? It doesn't matter which order you write the equations in your system. All right, something else that we could do is you could multiply an equation by a non-zero constant, okay? So let's say that we were trying to get opposite coefficients and we wanted to multiply everything through by 3 here, right? So that the x's would fall out or eliminate when we added those together. So we can multiply by 3. That's another. Or multiply, like let's say that in one of your equations you had 2x plus 4y equals 8. I don't really want to multiply by something. Maybe we want to divide everything through by 2. Well, that is the same thing as just multiplying everything through by a half. So that still goes with this second elementary row operation that we can do. Multiply by a half. That's also dividing by 2, okay? Now, on the last type is we can add a non-zero multiple of one equation to another. This is where that addition method gets its name. We can add these things together. Now, the first thing we would want to do is what we did up here above, and that's multiply everything through by 3. Okay, so you multiply by 3, and then when you add the equations together here, it says, we're going to get y equals 2. Okay? So those are the moves we're going to be doing. We can swap two equations. We can interchange two equations. We can, the next one, multiply an equation by a non-zero constant. We can add a non-zero multiple of one equation to another equation. These moves are called elementary row operations. Okay? And here is some more examples. So we've got the 3 moves, interchange 2 rows. Now in matrix form, instead of equation form, in matrix form, it looks like this. Okay, our first row would be -3, -5, -13. The second row would be a 1, 2, 5. We want to have the 1, 2, 5 in the first row instead of the second row. Now, I'll go ahead and tell you that you're going to want to do that because you're going to want a 1 right here. Because the reason is you want to know what is 1x, not what is 3x or -3x. You're going to want a 1 right here. Sometimes that's called your pivot number. Now, the way that we are going to notate the fact that we are interchanging 2 rows is that little notation says we're going to interchange row 1 with row 2. So we're gonna track our changes as we go through here. Number 2, it says you can multiply a row by a non-zero constant. That's the second one. So let's say what we want to do is we want to multiply row 1 times 3, and that's going to yield, that's what that arrow means right there, that's going to yield a new row 1. Okay? That's the notation you want to get down. Okay, to track what you did, but essentially we are taking 3 multiplied by row 1 to get a new row 1. Okay, that's the second thing. The third thing you can do is you can add a non-zero multiple of row 1 to another row. Okay, so this is kind of like a combination of 2, also used with the addition property. Okay, you can add those equations together. So the way we're going to notate that we want to, the reason we're doing this is because we want that to get away. We want that to become a 0. Okay, That was a pretty great thing when those bottoms were a 0 right in here, because what that allowed us to do, that's what we're headed toward right here at least. That's because what that allowed us to do is to be able to locate what, pretty easily, one of our variables would be. Z is equal to 2. That's what that means right there. Z is equal to 2. So that's what we're going to try to get on purpose. Okay? So the way we're going to notate this is we're going to take 3 times row 1, okay? 3 times row 1, and I kind of like to get off the side of my paper like they did here. 3 times row 1 added to row 2 to yield a new row 2. We're going to write that out like they have here. 3 times row 1 added to row 2 to get a new row 2. So here we've got the 3 times row 1, right? Okay, 3 times row 1 would give us a 3, 6, 15. Added to just row 2 copied down right here, exact same. And then you add them together to get a new row 2. 3 minus 3 is the 0. 6 minus 5 is 1. 15 minus 13 is 2 to get the new row 2. Those are some of our elementary row operations. Okay? Now, it says when we add a constant multiple of one row to another row, we don't change the row that was multiplied by the constant. Notice right here, okay, this row that we were multiplying by 3 doesn't have to turn into and stay the 3, 6, 15. It can go back to its original coefficients of 1, 2, 5. That's what the purple box is saying. Okay? You'll see us do that a lot here. Okay? Now, it's here's another bit of terminology. 2 matrices are said to be row equivalent if one matrix can be transformed into the other matrix through a series of these 3 elementary row operations: interchanging, multiplying a row by a constant, and then adding a multiple of one row to another row to get a new row. Okay? I know that's all kind of confusing right now, but given this matrix, we're going to see what it looks like to perform these elementary row operations on this matrix. 1, 5, 6 augmented with 2, 2, 1, 5, 1, 4, negative 2, negative 3, 10. Now, this row 1, and then the little double arrow here, row 2, means interchange row 1 and row 2. Now, when we interchange row 1 and row 2, that's going to give us a new matrix that's going to look like 2, 1, 5, augmented with 1. Now our new row 2 is what was row 1, the 1, 5, 6, 2. And then the third row, we didn't do anything to it. It's still going to be 4, negative 2, negative 3, 10. That's it, okay? All we did is swap row 1 with row 2, all right? Now, on the next one, we're not working off of this purple one for these, okay? What we will be doing later on is we're going to be working progressions. We're going to take the last matrix we had and then work with it. But on number 30, it just says to take half of row 2, and that's going to give us a new row 2. So really all that's saying is that we're going to take half of row 2. That's all that's changing to get our row equivalent matrix. It still has the same row 1, 1, 5, 6, 2. Okay? But now row 2 is half of what it was. 1/2 times 2 is 1. 1/2 times 1 is 1/2. 1/2 times 5 is 5/2. 1/2 times 1 is 1/2. Row 3 hasn't changed. It's still 4, negative 2, negative 3, 10. This blue matrix here is what we call row equivalent to our original matrix in our problem above, right there. All right, on number 32, what we're going to do is the directions say here, we're going to take -4 times row 1, add it to row 3, and that's going to give us a new row 3. Okay? So the way I like to track those changes is I like to write this but in vertical format. We're going to take -4 times row 1, then it says here added to row 3, and we're going to get a new row 3. So there's the directions on what we're going to do. I'm going to kind of organize it that way. And then we're going to actually put the values in right there. Okay? So if I take, for this first line right here, if I take -4 times row 1, I'm going to now have entries that look like -4, -20, -24, augmented with, I didn't quite have enough room there, augmented with -4 times 2 is the -8. Okay? I'm going to add that to, it says right here, row 3. So let me copy over row 3, and I'll have a 4, -2, -3, 10. And now I'm going to add these numbers together. Okay? -4 plus 4 is a 0. Ooh, I like the 0 right there. That's why we're doing it. -20 and a -2 is -22. -24 and -3 is a -27. And -8 and a +10 is 2. So now here is that new matrix after I perform that elementary row operation. All I got is a new row 3. That's the only thing that changes is my new row 3. Everything else is the same as what it was. I still have, even though I messed with row 1 up here, I still write the original row 1 of 1, 5, 6, 2. Okay? The second row, we didn't mess with it at all. It's 2, 1, 5, 1. But now my new row 3 is 0, -22, -27, and 2. Okay? So we like that. We like to get it like this only because we have a 0 right here. That's going to be one of our goals. Okay? So remember these 3 elementary row operations. These are your moves when working with these matrices. Interchanging. Multiplying one row by a non-zero constant, adding a multiple of one row to another row to get another row, okay?